problem B4. Here we have this plate with the thickness of T, and the shape of it is a parabola. So the equation of this line, we can write it as y is equal to k times x squared, which k is a constant number. And you can find this k, these constants, by using the coordinate of these 2 points, because this point is a part of this curve, right? So it should satisfy this coordinate. The coordinate of this point is b over 2 and h. So if you put b over 2 for x and h for y, you are going to be able to find k. So let's do that first, because we are going to need the equation of this line later. Y is equal to k times x squared, and so h is going to be equal to k times b over 2 squared, or k is going to be equal to 4h divided by b squared. And the question is asking what is the mass moment of inertia about the x-axis. So again, you have different choices for your element. What do you want to choose as for your integral element? Probably the simplest choice is using horizontal strips. So if you choose this tiny block with the height of dy, and the distance of it from the x-axis, let's say it is y, we are choosing this horizontal strip because all the points on this element, they have the same distance from x, right? And because of that, we can use the definition of mass moment of inertia to calculate the mass moment of inertia of this object about x-axis using this integral element. So r squared times dm, this is the definition again. R is the distance of my element from the x-axis, which is going to be y. But what is dm? That's usually, sometimes, it is a difficult part. So dm is going to be rho times the volume, and the volume is this area times the thickness t. So the height of it is dy, but what is the length of it? What is the width of this? I can use the equation of this line to find the width, the length of this object, right? So from here to here, if I call it x, then from here to here is y, right? So y is going to be equal to k times x squared. So x is going to be the square root of y over k, right? And the length of this element is going to be x plus x, 2x. So dm is equal to rho times thickness times dy times 2x. Because we have dy here, it's better to write everything in terms of y. So at the end, we are going to be able to do this integral if we do that. So it's going to be rho times t times dy times 2 times x. As I told you before, based on this equation, x is equal to y divided by k square root. Now, if I put all of this here, then ixx is going to be equal to integral of r squared. R is the distance of my element from the x-axis again, it is y. So y squared times rho t 2 times square root of y over k dy. Everything is in terms of y, and y goes from 0 to h. I can take out all the constants, which is 2 times rho times t, and divided by square root of k. Then integral of y squared times y to the 1/2 altogether y to 5 over 2. 2 plus 1 half, 5 over 2 dy from 0 to h. An integral of y over 5 half is going to be 1 over 7 over 2, or 2 over 7, times y over 7 to the power of 7 over 2. So it's going to be equal to 2 rho t square root of k times 2 over 7 times y to the power of 7 over 2. From 0 to h is going to be h to the power of 7 over 2. So we have this complicated equation for ixx. But as always, we want to have this I in terms of the mass. We need to find the total mass in terms of rho, thickness, and also B and H. If we do that, we can actually find I in terms of mass. So what is mass? M is equal to integral of dm, right? This is trivial. And we have an equation for dm. If you put that here, rho times t times 2 times square root of y square root of k times dy when y goes from 0 to h. And we can do this integral. Again, you can take this 2 rho t divided by square root of k. The remaining is going to be a square root of y. The integral of it is going to be 2 over 3 times y to the power of 3 over 2. From 0 to h is going to be h to the power of 3 over 2. So this is mass. You can separate the same term, similar terms here, and replace it with mass. So ixx is going to be equal to separate similar terms, I'm going to have 2 rho t the square root of k times 2/3 times 3 over 7 wait, before that I need to have this term here too. So h to the power of 3 over 2, then 3 over 7 times h to the power of, if you subtract 3 over 2 from 7 over 2, it's going to be 2. And this is mass, right? The only thing I did here, I separated these terms from this. The other way you can do it, just calculate ixx over m. Then you need to divide these two together, and a lot of these terms are going to cancel out each other. Then the remaining is going to be 3 over 7h squared. Anyhow, ixx is going to be equal to 3 over 7 times mass times h squared. That's I. To calculate the radius of gyration, we need to divide it by mass, then take a square root of it. So kx is going to be a square root of 3 over 7 times h.